This conference will now be recorded.
Hello, mic check. Can everybody hear me?
Yeah, I can hear you. I'll mute your mic now.
Okay. All right. Hi, everybody. Welcome back to class. And today we'll be continuing from where we started yesterday. And we're going a little in depth with NodeJs. So far, what we've covered is just like talking about the introduction to Node.js, how Node.js achieves um, giving us a JavaScript runtime server side. So today we'll be going into a little bit more complicated functionalities that we can achieve with Node.js. And so first on our list is middlewares. Next we'll cover HTTP, and hopefully HTTP is a broad topic. Hopefully, if we have enough time, we'll cover static assets as well. If not, materials will be provided, and we'll also touch on it in the Thursday class this week. Yeah, you also get this slide as well. I would improve both slides. There are a few corrections from the one from yesterday. There might be some corrections to the ones today. Yeah, so essentially they're living documents as I find things that I think are important for you guys to know about. I'll add them to the slides. So you always have a link to it. All right, let's get started. So first things first, we are talking about middlewares. So in general, middleware is, like the name implies, is something that sits in the middle between two other things. But in the context of like computers and computer software, like your computer you're listening to this class on, or you're attending this class on, has middleware. Middleware just essentially refers to software that lies between, in the broad sense of computer science and computers. Middleware just refers to software that lies in between your operating system, which is Windows, Mac, Linux, whatever the case may be, and the applications and services running on your computer. So what does the middleware do rather? It serves as the middleman between the programs. So sometimes yeah, there might be some processing you need to that your program needs before it is able to do something. So most of the time you have middleware programs that sit in between your user inputs and your actual program. So maybe a middleware might serve as so you can in some instances it serves as a filter. So for example, if you're writing a program that takes like a note taking app, and you wanted to filter out bad languages, like you don't want people to use foul language in the note taking app or some kind of dictation app, you would implement like a middleware that is basically just sitting in between your program that's handling inputs on the keyboard and your actual program that is taking that input. So the middleware sits in between, acts as the filter. So it first of all gets the input and says, "Oh, this is the input. Does this input jive with what is allowed for this application? If it doesn't allow it, filters it out or returns, and it sends back an error. So whoever is using the program knows that, oh, I've entered something wrong. So that's what middleware does. But for us, since we are talking about Node.js, so in the Node.js context, middlewares are they're just simple functions that have access to our request object or our response object at the next function. We'll find out about all this. I spoke about when I referenced that example where we built this where we looked at some sample code about writing a server in Node.js. We saw what the request and what the response object does. I'll speak more to it in coming slides, but our context, which is Node.js, middleware just refers to a function that has access to your request and the response as well as the next middleware function. Okay, So we've covered something. So any questions so far? All right. So moving to the next next topic, we are still on middlewares, and like the name suggests, middlewares always come in between something, and particularly with Node.js, most will primarily be dealing with writing servers. That's what we'll mostly be doing in Node.js, and this is very pertinent to the projects you are working on. So you've built out the front end. Next thing you need to build is a server to handle requests to your application. Servers that will help you actually learn about. So middlewares are something that is very important for you to know. So like I already mentioned before, like the name suggests, middlewares sit in between the middle of something, which is the request response cycle. The middlewares have access to the requests and the response object as well, and they also have access to the next function of the request response lifecycle. As you can see in the diagram now, we can see a classic example of the middleware. So you have your client request that's coming from your mobile app, your web application, your CLI tool, whatever client that you have that is making a HTTP request sits at the left-hand side or at the input side. Then you are your server, which is a collection of middlewares, sits in between, receives that request, processes it, does some processing on it, and provides a response to the client. Like I spoke of yesterday, most applications we use in our everyday lives all use the client server model where your client, that's your mobile app, your Instagram app, your Twitter app, makes a request to a server for information or sends the information to a server to store. We use it every day in our lives, even when we don't know it. So, but now we're going to be learning how to build those servers. Okay, so yeah, like I said before, middleware functions can perform a bunch of tasks. They can execute code. They can modify the request and the responses. They can end the whole request response cycle. They can call the next middleware in the stack. So this is another important thing to note. So most times when you're building out servers, you won't have a single middleware. You might have a part on your server. What's something about that? That you need to do multiple validation steps before you can finally uh, give the client a response. For example, say we are working on our time off app, and we need to be able to check whether this user uh, uh, has been confirmed. You know, like in a traditional professional setting, you have to be confirmed at your place of work before you can apply for leave. So, like typically for most companies, 3 to 6 months, that kind of thing. So you would maybe an employee within our application might request for time off. Our app should be able to the servers for our app should be able to say, oh, this person is not qualified for leave yet, that type of thing. So you might have middleware functions that do these checks before providing a response to your web application, telling the web application that saying, oh, this employee that requested for leave is not eligible for leave because he's still on probation, that kind of thing. I know I've just said a lot. I hope everybody understands that. Okay. Okay. Thanks everybody got that, but I'll just go over it again. So the middleware can execute code. So like I said, the middleware is a function, and every function has this thing, code statements inside of it. A function is a set of instructions. So a middleware can execute a function that executes code essentially. Then next point about it is that I can make changes to the request response and response object. So example, a request comes in and we have a middleware that intercepts it. We can modify that request and add a little more stuff. Hello, hello, somebody saying something? Okay, I think somebody's mic was on. Okay, so I'll go over that again. So we can with the middleware we can make changes to the request and response object. So, for example, a request can come in. We can decide to add a middleware that checks whether the person making the request is logged in, and if we see that a person is logged in, we can add the person's user details, maybe his first name, his last name, all those type of things. We can add it to the request object so that the next middleware can also access it and do some other kind of operation with it. Or we can modify the response and say if the previous middleware gave us a response in fraction, maybe we've simply written it to calculate when you want to convert the temperature of a temperature value from say Celsius to Fahrenheit, you make a request to the server. So our first middleware will do the actual calculation. Then maybe we have another middleware that converts the Celsius value to Fahrenheit. So we'll modify the request after we've calculated it, adds the value there and send it to the next middleware. The next middleware will now modify it and set it in the and put it in the response so that the client can get the final one. So the next point there is that a middleware can end the request response cycle. For example, if you had a middleware that was doing data validation, so you had yeah, like let's also use our temperature conversion calculation. You wanted your server to only take whole numbers. So you wanted to add validation, and you write a middleware that has some validation code that says if a number is not a whole number, we reject this number. So essentially, you can now use the middleware to say if the request that was sent to me doesn't have a temperature value that is not a whole number, end the request. That is achievable with the middleware. The middleware too can also call the next middleware in a stack. Like I said, a a request handler for a request a server can have multiple middlewares attached to it. So you can have zero, you can have 1 to n middlewares, and all of them are put in a stack structure. I'm sure, if I remember correctly, you guys learned about data structures earlier on when we started the full stack program. Earlier on, you learned about different data structures, queues, stacks, lists. So um, middlewares are typically aggregated in stacks. So they're executed in the order at which they were added. If you added a middleware for validation first, it's the middleware for validation that gets called first. If you added another one to fetch data from the database, that will be called next. Like that, they'll be handled one after the other, except one ends the request response life cycle. Is that clear? Okay. Like I already pointed out, to say if a current middleware function does not end the request response cycle, it should call next, which means that just imagine this as a factory line where we are producing cars. Materials are getting added to the assembly line, and we are building out the cars and is moving along the production line. If there's a step along the line that decides that I don't want to move forward and doesn't say take, I'm done with my part, and doesn't say next, take, carry on, that whole process hangs. So it's the same thing with the middlewares. If you have 10 middlewares and the middleware at the number 4 middleware decides that or was poorly written and doesn't call next when there was an issue with it, or is not ending the request process, the whole request process now hangs. So the client that made the request now is waiting for a response, and it's waiting, there's no response. So it hangs. So that's why uh, clients like your browser implement timeout mechanisms. So the timeouts are just simply a policy. So when you make a request, the browser sets a policy that I should expect a response within 30 seconds or 40 seconds. If I don't get a response with this time, then I know that there's an issue. I'm going to cancel this request. So are we starting to see how like some of the errors that we might have seen in our day-to-day life? We can see when we're interacting with the internet, we can see where they stem from now. When you go, you try, you're trying to access maybe the NYC websites or NNPC websites, like everybody's trying to access now, and it's all slow and the rest. It's because a lot of people are accessing it at the same time, and the middlewares that they have set up to process requests and get things, fetch things from database here and there, they are getting clogged up with too many. They can't respond in the, I like to call it an SLA, like it's a sales lease agreement. For example, if you work in say sales, or you're working you're an internet provider, somebody will ask you what is the SLA for your network. You will typically tell you that our network has 98% uptime. That means 98% of the time the internet network should be available. That is the SLA they are giving you. That is there's, sorry, not sales level, service level agreement. So if they violate that, they might have some recompense to pay. So it's essentially the same thing that happens with browsers. The browsers give servers an SLA. You have 30 seconds to respond to me. If you don't respond in 30 seconds, I'll time out. Great. I hope everybody understood that. All right, so I'm making progress. Yeah, sorry. Yeah, so like I said, the middlewares are arranged in a stack structure. So you can basically see them. So, for example, in this diagram here, we have a client request coming in, and we have 5 middleware functions. We have 5 middleware functions before we actually get a response back. So the request comes in, the first middleware processes it, and when it's done, the next method is called. So it moves to the next one. Same thing happens there. It does the process, it calls next, moves to the next one, moves to the next one. By the time it gets to the last one, he expects that this last one would actually provide a response. If this doesn't provide a response, the entire request response lifecycle is now stuck. So yeah, like if in this statement here, we are saying a middleware is basically a function that will receive the request and the request objects, just like a root handler. We'll talk about root handlers as well. And as a third argument, you have another function which is called next, which essentially you should call in your code once the functionality you are running in your middleware is completed. That means essentially you can do things like wait for your database call, or you're making you can inside the middleware you can even make another a request to another external server to fetch some data and maybe add it to your request object before moving on to the next step. But you also have to take note that there's a time penalty for every step, every middleware you add. The more middlewares you add, you are slowing down the response time. So as much as possible when you're building, you have to ask yourself, is it worth it adding more middlewares? Can I do some of this within my previous middleware? Can I combine these functions in the middleware, or can I defer the process of fetching this data to another step? Does the user need this information in the response? Or that those kind of questions become very pertinent. But over time, we would learn how to make um, the best decisions when we are writing middlewares. All right. So next, we are going to be talking about HTTP. I'm just going to give like a brief overview of what HTTP is, just for the sake of working with Node. Ideally, I'd prefer that everybody takes a couple hours and just does some research and just figure out, let's just read about HTTP. And if you have any questions, you can email me like you normally do, and I'll be glad to answer those questions. So let's talk about HTTP. HTTP is, yeah, okay, somebody's asking a question here. It says, is Demeter is asking if the process from the client to response is one way. Yes, it's one way. Once a request comes into the server, the next step is to provide a response. Like I said yesterday, it's like a conversation. When you say something, you expect a response back. So it's one-way traffic. So you make a request, then it comes back to you. But there are other protocols outside the HTTP that provides bidirectional flow of data. When I mean bidirectional, the data can flow both ways from the client to the server and so the server back to the client over a single connection. We'll get it's I think that is also in your curriculum, so we'll learn about that soon. Okay, so back to HTTP. HTTP is one of the most fundamental protocols that powers the internet. So HTTP is just short for the Hypertext Transfer Protocol, and it's built on top of some other low-level protocols that the internet uses: TCP, IP, and UDP. I'm not going to get into all those ones because if we get into that, we'll start getting into advanced networking topics. And yeah, it can be a bit of a rabbit hole because you find that there are sub protocols of protocols and so many, should I say, peculiarities on depending on how the protocols are used. But primarily today, if you are communicating with the internet one way or the other in your browser or your mobile application, your Instagram, your Facebook, your Twitter, your email clients, almost every piece of technology you use in your daily life, especially from your mobile phone or from your computer, is using the HTTP protocol somehow. So what is the HTTP? The HTTP protocol is a protocol that allows the fetching of resources from remote computers. So mind you, the internet is not just one big massive computer sitting down somewhere where everybody is receiving information from. The internet is just a network of computers connected to each other all over the globe, millions and millions of computer systems connected to each other. So every time you open a website, you're essentially fetching a document. The website is the document. You're fetching that document from someone else's computer. In this case, the person's computer might be Google, might be Amazon, might be Facebook, or one of the big internet companies that have their own internet infrastructure. That's essentially what we are doing. Today, I'm talking to you. I'm also talking to you through using somebody else's computer as a proxy. We are also communicating over a protocol. So you're also communicating over a protocol. So HTTP is one of the primary protocol used in your web browser. The other one protocol is still based on HTTP, but the difference is that it is secure. So sometimes you open your browser, you see HTTPS. It's still HTTP, but it's a secure version of HTTP. It just has more security attached to it, and we'll learn about that over time. So yeah, in a nutshell, HTTP is a protocol that allows the fetching of resources such as HTML documents. And like I said already, it is the foundation of any data exchange on the web. And it is a client-server protocol, which means that requests are initiated by the recipient. The recipient in this case being the client. And like this statement says already, usually the web browser. So a complete document is reconstructed from the different sub-documents fetched. For instance, text, layout description, images, videos, scripts, and more. So when they say layout descriptions now, you're talking about HTML. HTML is just saying this is the structure of the document. Then you have CSS that are just telling you how do I position things, what color do I give to things. So all these things that we do every day is all made possible by the HTTP protocol. Okay, any questions? I know this is a bit of an eye opener for some of us. This is what's working with on the back end kind of does for you. It opens your eyes to how um, the services you take for granted in your day-to-day life are really built. So you kind of have it gives you a better appreciation for the work that goes into building internet services. Okay, let's move on. So HTTP as a protocol has allows you to send messages, and there are two types of messages: requests and a response. And each of these message types have a format to them. So we'll talk about requests first. So a HTTP request has this format. It must have a method, it must have a path, it must define what protocol version is using. It may or may not define headers, and it also may or not define a body. I'll go over each of them one after the other. Uh, sorry. I'll go over each of them one after the other. So we have the HTTP method. The HTTP method um, is simply a way of hold on, just give me a second here. I'll just stop sharing my screen briefly here, and I'll get back to you guys. Sorry, in 1 minute. I hope everybody is following so far. I think this is a very interesting class. Yeah. Okay. So yeah, I'm going to share my screen now. Okay. Yeah. So we are talking about HTTP requests, and I just said a HTTP request follows this format. It needs to have a method, it needs to have a path, it needs to have a protocol version, it needs to have may or may not have headers, and it may not or may not have a body. So what is a HTTP method? A HTTP method uh, is simply another is a set of rules defined by the HTTP protocol that says to make a request, you need to define the method of the request. So the method of the request simply is just there to indicate the desired action for that request. It essentially says what are you trying to achieve when you make the request. That's what the method says. So there are like I think there are about 7 or 8 methods thereabouts. I'll just go over them one after the other. The most common ones. So there's a get, which is I'll just show you this over here. So we have get, and mind you, all of them they are always in uppercase letters. So you have get, you have post, you have put, you have delete, you have patch. There are a few other ones that are not here. You have options, you have trace. Yeah, you have options, you have trace, you have connect, but those ones are not commonly used. Most of the time, you never actually have to use any of them because they are used like on an internal basis, especially the trace and the connect one. Most of the time, I can't even remember what connect and trace does. Well, like the get method implies that the HTTP request you are making is trying to retrieve data. So the names are almost self-explanatory. Oh yeah, let me not forget. There's also a another method type called head. Yeah, funny names. And it's not and the funny thing about the head method is that it's not very self-explanatory about what it does, but it's very similar to the get method as well. It's trying to retrieve data, but the only difference is that it does not have a request body. But on the other hand, a get might have a body, but it's very rare for a get request to have a body because of the different specifications that have been created over the years on how to use these HTTP methods. So yeah, so the get method is just when you make a HTTP request with the get method, the assumption always is that you're trying to retrieve data. Then when you make a request with the post method, the assumption is that you are trying to send data, you're trying to submit data that is going to cause a change in state or some kind of side effects when that data reaches the server. Then you have the put request. So the put request here is simply the inverse of the post request. The put request here, the assumption is that you are trying to replace some data that already exists on the server. Then we have delete, and like the name implies, it means that you're trying to delete something. Then lastly, we have patch. Patch is it's kind of like a put request, but a patch request is simply applying partial modification to something on the server side. Yeah, so essentially we've covered the top 5 and the most used HTTP methods. Does anybody have a question? Any questions? Yeah, so we crowd. We get to that soon. We'll soon see that. So next thing I'm going to talk about is the path. The path is also part of the request format. Okay, we have some questions here. Somebody is asking where does patch come in their book. So yeah, so I think you and Temita have similar questions. So patch is typically used to do modifications, like partial modifications. Say you have a database that stores employees, and you wanted to modify, and one of your employees got married, and you wanted to modify her last name. You would use a you use a patch request. Ideally, you would use a patch request, and you would just say for this particular employee, I'm trying to patch uh, her data, and I'm just going to patch her last name and change the value. Whereas if I wanted to overwrite it, going by the HTTP specification, if I wanted to overwrite that entire employee, I would make a put request. But the reality is that in current implementations that we all use today, most applications don't use the patch method. Because most clients today, or in the past, I know most clients today support, but in the past, like 3.4 or a little bit more than that, most browsers didn't support patch HTTP requests. So what most developers did was they turned the put method into a hybrid of patch and of the patch and the put. So a put method can act as can do an overwrite, and at the same time it can make a partial modification. But in your case, most of the time, I highly doubt that you'll be using a patch request, except whatever clients that you're working with, whatever clients you might be building to make those HTTP requests supports patch. But I know for a fact that up until recently, most clients didn't implement the HTTP patch method. Exactly. All right. So we're talking about the next item in the format for HTTP request, which is the path. So when you're making a request, a HTTP request to a HTTP server, you need to specify the paths. The server needs to know what paths within this server you are you trying to make a request for. So typically in modern day a modern development, developers now use use the parts as a way to as a route handler, as a routing system. So, for example, if I was writing a server and I was trying to implement some kind of API, like I said yesterday, an API is an application programming interface. It's just is a user-defined protocol of how a client can make a request to fetch a particular type of resource from the server. So say we had let's think in terms of our application that we're building, which is our time off application. What are our resources? Our resources are the most important resource in our application is our employees. So we wanted to fetch all the employees within our system. When we were building the server, we would create some kind of routing system that says that every request that comes to the server and has a path that says / employees. Once we receive such a request coming to that path, we would fetch all the employees on our database and send it in a response. So that's what the path does. It serves as a routing system, a way to identify what the request is looking for. Is that clear? Do we all understand that? All right. The next thing I'm going to talk about is the protocol version. So, just like most things in life, the HTTP protocol is not static. Every now and then, the working committee that is responsible for maintaining these HTTP protocol specification might come together and decide that in order to fix some problems that they have discovered with using the protocol, with people using the protocol around the world, that they have decided to include a new format of some kind, or allow the protocol to do something that it was not able to do before. So once they do that, they increase the versioning of the protocol. So currently today, there are two main versions of the HTTP protocol available for us to use, which is HTTP 1 and more recently HTTP 2. And both of them all have unique features that they support. HTTP 2 is said to be faster than HTTP 1 because of the way it handles data transfer between the client and the server. So that's a topic. That's a very long conversation for another day. Hopefully, we'll get to have it. But basically, that's what the protocol version does. It just allows the server know that this request is coming with is using this version of the HTTP protocol. That way, the server can decide whether it can handle it or not. Then the next thing we have is the headers. So the headers are kind of like identifiers, they can be identifiers, and they can also be additional information for the request. For example, now in this example we have here in the image, we have two HTTP headers here. We have the host and we have accept language. We can already infer what this means. So the accept language header there just telling the server that this client would only accept languages, will only accept a response that the language it prefers to accept a response that the language is in FR. FR is like the ISO code for the short name for France. So it expects a response in French. And the host here is simply specifying what is the host of the server that this HTTP request is going to. The host is simply just the domain name, developer.mozilla.org. It can be google.com, it can be paystack.com, it can be facebook.com. Then, like I said, the headers can be optional, which means they might be there or they might not be there. But most of the time, headers are always there by default. Your clients will typically inject some headers, especially your browser. Some of you has a question. Some of you, I don't think I understand what your question means. Can the header be level? Can the header level be up to .com? I don't understand that. What do you mean? So the headers are free form. They are not. There's no hard and fast rule on how to uh, write how to space header values when you're writing them. I think I have some notes about that here. So like I said, HTTP headers allow you, the client and the server, to pass additional information between themselves, either in the request or in the response. And headers are contextual. So depending on the parts or the server you're making a request, you might require some headers to be there, or you might not require those headers to be there. But it's basically it's free from key. So you have a key being the host, and the value here being the developer. So this is the key, this is the value. You are both strings. Is that clear that? Okay. So the next thing to note about HTTP request is the body. A HTTP request might have a body or it might not have a body. So some HTTP requests, so especially if you're making a HTTP request, they get method. Half most of the time, a body is not expected. If you're making a put request, then a body is expected. If you're making a post request, so the body is optional, all of them, but the assumption is that if you're making a post request or a put request or a patch request, there should be a body, because you're trying to modify information or overwrite information, or you're trying to add information to your server. Okay, I see another question in the chat. Yes, Ayo. Yes, a content type can also be a header. So the content type header is just a way of telling, um, of just of telling the client the content type to expect. So, for example, when you access a website and your browser is downloading it, the server always responds with the content type as text slash HTML, telling your browser that the response I'm going to give to you is HTML. So you need to be able to pass that HTML and build a web page out of it. So that's what the content type header does. All right, moving on. So next thing we're going to look at is HTTP responses. And like HTTP requests, HTTP responses also have a format. You must have a protocol version. You must have a status code. You must have a status message. You may or you may not have a header, or you may or you might not have a body. So let's look at this example here. We have the protocol version here. This is the status code, and this is the status message. So the status message is just a brief description of what the status code means. So the HTTP part of the HTTP protocol specification is that every request response should come back with a status code that indicates the status of that request. So there's a predefined set of status codes. That will also be made available to you in some study materials after the class. Common among them is 200. 200 indicates that everything went okay. I can't really necessarily, I don't like, so you probably just take note of about 10 of them, because they'll become part of you. So you get 200, which is everything is okay. You get 201, which indicates that, oh, your request was accepted. You have 202. I can't even remember what 202 means, or 203, but the common ones are 200, 400, indicating that you made a bad request. 404, indicating that what you requested for cannot be found. 401, which says your request was not authorized. 403, meaning that your request to that resource, your permission was denied, then you get, I think, there's 409 that payment is required in order to access that request, that resource that you're trying to request for. You need to make payment, and there's 500 that says that indicates that there was an error with the server, internal server error. Then you can get some of them in the 500 ranges, 502, 502 meaning that there was a timeout. The server couldn't respond in time. There are 503, yeah, and there was a server error. I couldn't handle it. So there's an exhaustive list. I also I recommend that you just keep track of the more commonly used ones and you don't keep all of them in your head. Just make sure you have like reference material that can always go through when you are designing your APIs that you are building on top of the HTTP protocol, because that's what you are going to be doing mostly with the HTTP protocol. You'll be building your own APIs for your own clients, your mobile app, your web apps, and your desktop web applications. Those will be your clients making requests using your API which you have built on top of the protocol. Somebody said that our brains have more than the capacity of Google. Yes, I believe that, but with our day-to-day life, we tend to forget some of these things. I think what I find is that is like muscle memory too. As you start building more and more stuff with this, it becomes second nature to you. Okay, so let's jump back into this again. Let's look. We can see the headers here. So we are getting some additional information here. We can see there's a date header that's telling us when we got the response back. The server type. So there's another thing to note too. So while we're working with Node, we can write our own servers, but outside the Node.js ecosystem, for other people have, like I said, programming is almost like a community effort, because most of the time you think about building things, tools for yourself, you find out that somebody has already done it, and you can just use what the person has done, and that will allow you to build things faster. So in our case, we're going to be writing servers with Node.js, and amazingly enough, some group of people already built out different servers. There are so many servers in the world. There's a Tomcat server, which was built in Java. You have Apache, which was built, I think Apache was built in C++. You have Nginx, you have Kadi, you have HA proxy, you have Envoy. There are a ton of them out there. So typically, most HTTP responses always have a server, they always have a field within the header that indicates the type of server that responded to the request. So in our case here, in this our example, we have Apache. Mind you, this is just an example. When we do ours, we'll see what the response will get back. So there's more information here. Like I asked about this, what happened? What does the content type mean? We can see in our header here we have a content type of text/HTML. So for example, once the browser gets this response, it can look at the headers and say, oh, when the response came back, the content type is this. So this basically indicates to me that this is a HTML page. So I can render this in the browser. So you also get information like content length. What is the size of this document or this data that's getting sent back to the client being the browser. So this is about 29,769 bytes, which I think thereabouts roughly translates to about 29 kilobytes, give or take, or approximately 30 kilobytes if we approximate. So yeah, that is HTTP request. HTTP request can also have a body. So we'll talk. I'm not talking about the body when we are talking about HTTP requests and HTTP responses. We'll see that in our examples when we start writing code. All right. Any questions so far? Okay. Somebody has a question. Ayo, can you ask a question? Let's take a 5 minutes break just for questions. So you can unmute your mic and ask a question. Okay, go ahead.
Hello, can you hear me?
Yeah, I can hear you. Yes, I can hear you.
All right. I wanted to ask, in building when you were talking about the HTTP, and then
Yeah,
how that when we're building APIs, we have to return like with next. That's right. I wanted
yeah,
to ask that when building APIs, why is it that sometimes the maybe when we build on our local machine, you build APIs and
mm,
then you get responses. Like you get
yeah,
outputs when you test it with the like Postman. But when you put it
yeah,
on server like maybe Heroku, instead of it giving
mm,
you a response, it's giving you like timeout and things like that. Meanwhile, it does not do that on the local server. But when maybe someone like load your API and like
mm.
connecting it to Heroku, instead of it giving you the normal response, it's saying um, um, server error like I see the timeout and things like that. What could have caused? Is it because of what you explained, or there's another issue concerning that?
All right. So what happens most of the time is that your code is no longer running on your local machine at that point. Could you mute your mic? Yeah. So what is happening at that point, your code is no longer running on your local machine. So it's a different environment entirely. So this is one of the more common things that you face in your development career. It's something I see almost every other day or at work. You hear people complaining that, oh, this thing was working on my computer, but when we deployed it, it stopped working. The environment is different, the configuration is different. So you can't always expect the same results. So to solve that, people have come up with different methods of ensuring that the environment they are working in locally is very close to what they are going to be deploying to. So most of the time that's the case. Or in other times it might be a configuration issue. Maybe you have a configuration that is not set or doesn't have the correct value. Those are the two common causes of issues like that. Does that answer your question? All right. Okay, so now we are going to be sorry. So now we are going to be looking at some examples. We are going to I'm going to write our own server to understand everything that we've been talking about. Okay, so we're going to write a simple server now. So if you have access to your VS Code, your code editor, you can you can write along with us. So I'm going to be using um, projects we created yesterday to get started. So I'm just going to write some sample code and we'll talk about the code and we'll try it out. And note, this is all JavaScript, so none of this should look very foreign to you. Is it legible enough for you guys now? Can you all see? Is the zoom level okay? All right. So luckily for a lot for us, um, Node.js has a HTTP module built in that abstracts away some of the work we have to do if we wanted to build a HTTP server from scratch. So it provides a set of utilities that we can use, which we'll see now. So first things first. So I'll be commenting the code. I'll be talking about the code as I'm writing. So first things first, we have imported the HTTP module. Next thing we're going to do, we're going to specify a port that we want the server to listen to connections for. Let's call it 3310. Yeah, so now we're going to create a server. Or better yet, we can let's create a server. So we say server, then we say HTTP, and we can see from it's already telling us. So you can see in the method signature is expecting there are two versions of this method now. So the first version of the method will just take a request listener. The second version will take some options and then a request listener. So we're going to be using the first one. And we're going to add our own request listener. Request listener is simply takes two methods, two objects rather, which is a request. You can see it's a request incoming message and the response. We're using the ES6 syntax now. So we can now handle whatever responses that come in here now. So inside here, let me just put something here. So we are going to do something now. I'm going to write this in a way so we can see everything that we have talked about now. So I'm going to simply say when I receive a request, I'm just going to do response.end, and I'm just going to say request received. That's all. But I'm not going to do something different here. I want us to see what is inside the request. So I'm going to do this. I'm going to say console.log, and I'm going to attempt to see what properties of the request that we can see. Let's see. We can see, since we have VS Code, it's already giving us some code completion. We can see some things here now. You can see the headers, you can see the HTTP version. Let's see which other properties. You can see the status code, you can see the status message, you can see the URL. There's something I'm looking for here. I can see the method as well. So let's do something. If you're not familiar with this syntax I just wrote down, this is called destructuring in ES6. It allows you to create variables out of the properties of an object. So what do we want? We want to get the method property of the request. We also want to get URL. We want to get the URL. We want to get the headers. Let's see, we want to get the HTTP version. Okay, so we can now log all of this. And we can now say, let's log and say HTTP method is using our template literals. I don't know that one. Let's see. Parts. Parts is URL. Let's get headers. So the headers is a collection of objects. So we can just simply say headers. HTTP request headers, and say headers here. Then last but not least, we'll log the version. Say HTTP request version. HTTP request version is HTTP version. All right. So we created the server, but now this server can't receive any requests unless we create a listener. So we need to be able to make it listen to requests. So we'll not simply say, okay, so the reason why someone is asking why we didn't use the string interpolation for the headers. So the headers are typically an object that has many properties. So I'm not looking for a single property within the header, so I just want to output the whole thing. So that's why I didn't use string interpolation on it. So I cannot say server.listen and specify my ports. Then I can add a callback. I say if there was an error, console.error. Error. If there was no error, we can now say console.log. Our server is listening for connections on ports. You will just simply specify the port there. So in 20 lines of code, we have written a simple server. So now we're going to test this. So to test it, to run this, we simply just invoke the server on Node. So we just simply say Node. Our server is written in the index first. We say Node index.js, and voila, we have a server running. So now let's actually make a request to the server. So I'm going to do something now. So we can make a request from a browser, or we can make a request from a mobile app, but I'm going to be using a command line tool called Coil, C-R-U-L. So I'm going to do that now. So I'll simply make the request. So just keep your eyes on this terminal here and see what is going to happen. Core HTTP localhost, which is our host machine now, and we are running it on port this. Can you see what just happened? Mike, did everybody see that? So essentially, we have just written a server. Okay, we can even take this further now and add something else. So essentially, now we have created a server and we have received a request. So let's take this further now and let's look at something else. I'm going to make another request, but this time I'm going to add something. Are you seeing that our request has changed now? You can see that the path now is different. Now we are getting the employees part as our path. You can see the request headers. It's telling us that the user agent where the request came from is core, and the version of core we are using. Yes, I'm using Coral as a client to make the HTTP request. And it's telling us that we're using, what we define, it's telling us that we're using HTTP 1.1 as our version. So Coral is just like a command line utility for making a HTTP request. So now let's do something different. Let's try and make a post request. So I'll modify our Coral command here and we'll make a request. So we're going to do this now. I'm going to say Coral, let's see, let's use JSON data. We'll also learn about that shortly. I'm going to make a request. I'm going to say, I'll close this. I'll close the server. I want to modify it and add something else. So I'm just going to log this. Then I'm going to also log this, the body. As well. So I'm going to do this now. need to send the JSON. Say first name Patrick, last name full. Don't worry too much about core because most of the time you might not be using core. But just for the sake of this, for the sake of showing you an example, I'm using core because it's just easier, so we can just work from inside VS Code and not have to open another application. So if you're using core, the option /d is used to indicate data that you are sending. So essentially now I'm adding a request by using that /d option. I'm sending a request body, and the /h I'll be using that to send a request header. So I'm telling the server that the content type is application JSON, and I use the X option to specify the method I'm using to make the request. Then I make the actual request to the server. And I say, look, I'll host this 33, 10 employees. So right now, if you notice, the server is not running. So we get an error. You see that? So I'm going to run the server again here. So it's listening for connections again, and I'm going to make that request. Okay, we have an error somewhere. Our request is not seeing the body, so it doesn't understand it. So this is now where we need to add a middleware. And like someone here has already pointed out, in Node.js to be able to handle the JSON data format, we typically need to use a middleware to understand that. But in our case, I'm going to handle that ahead of time, and I'm going to add my own middleware. So we're going to modify the server again. So we are going to do something now. I'm not sure about this. So the body parser is not meant to. You know what? I think let's use the body parser. So this would be a good way for us to get an example of how middlewares work. So 1 minute. So I mean, we could have easily used the third-party module to build our server, but I want us to understand how to use what do you call it? How to use Node.js without external modules. So I'm going to modify this a bit. So right now we're just logging responses. So let's add before we end this, let's add some more logic and say, let's say if our request method is post. Let's do some additional processing. Let's see, let's store the body in a variable now. Let's create an empty string variable. I will now say request on data. and just simply pass a function here that takes a chunk. Once again, this is ES6 syntax. Now we'll change this. Now we'll take away this, and we're going to say, so because this allows so the when we call the on method, it essentially returns the same instance of that request, so we can essentially chain more function calls to that. So let's put this here. We'll add another one to handle get requests. Just leave that here. Forget we don't want to do anything much. We just put this here and just end the request. Okay, so back to this. I'll explain what is happening here. So let's just say our body, anytime we receive a new data chunk, we just say, just add it here, and I say chunk, that's the string, and we have our body. So we can take this out of here and actually log here and see body here. Okay, let's test this out. I'm gonna send the request. Can we see what changed now? We are not able to see what was in the body of the request. So the difference was that by default, your server, when you create servers don't know how to handle the body of the data you send to them. You need to be able to. That's why headers like the content type, things like headers like content type are important for us to say, to be able to tell what the data type is being sent to the server. For example, now let me make a modification. Now I know this might be looking a little bit complex, but please bear with me. So let's make a modification now. Let's say, okay, if we're saying, let's add another condition now and say if this is a post request and the request dot headers, we have a key there called content type, and the content type, the value of the content type is application/JSON. We are going to run this, and what we are going to do now is, rather than just output, we are going to convert our body to a JavaScript object by changing it. So we'll now say, at this point, we'll now say body on end. We'll just convert the whole thing and say body is equal to JSON dot parse body. If we close that, open it again, and make our request. Okay, we didn't log it, sorry. We can now log the body here. So we close this and run it again and make a request. We can see now that we have turned that into a JavaScript object notation. Okay, I've been writing a lot of code, so it's time to break it down for everybody what's happening here. Okay, so I'll go over this line by line. So to get started, we imported the HTTP module from NodeJs. Then we defined a port for our server to receive connections on. Then we created the server. And in the process of creating the server, we created a handler. You know what? Let's make this cleaner. Let's define a handler separately. Let's say request handler, like we did in our example yesterday. It takes a request and it takes a response. Let's just make it easier. Copy this out and put it back here. Then we change this and just simply pass our request handler to it. So this might, okay. I think this is the perfect example to show us some of the things we're talking about yesterday. So let's turn our function here into a local module. So we just add a new file, we call it handler.js, and we'll take this here. I'm going to make our code cleaner. I'm going to put it here. And to turn this to local module, like we saw in our example yesterday, we simply say module.export equals to request handler. Then we go to our server now. We can now import this. We can now say request handler, and we now require our local module. And if we close this and run our server again, okay, sorry, there's an error somewhere. The naming convention is still request response in this function. So if we run this now, we should fix that. All right, so there's we have another question here. It says, where does include come to play? So Node.js doesn't have an include construct. Rather, it has a require construct. So I'm guessing you're probably looking at it from another language, PHP, but it doesn't apply here. So let's go over this again. So we've imported our HTTP module, which is a core module. We learned about core modules yesterday. We've imported it. Then our request handler is a local module within our project. We've also imported it as well. It's saved in another file here. We just did this to keep our code clean, so we don't have too much code in one place. Then we define the port that we want our server to run on. Next, then we created the server using the create server method of the HTTP module. So let's actually do something. Let's look at the definition of this function. So if I command click into this now, I can look at how this is like internally. This is how Node.js implements this create server method. So it's expecting a request listener. So we can actually look at what a request listener is supposed to look like. So a request listener is supposed to take a request and a response, and the request is of a type called incoming message, and the response is of a type called server response. So we can actually look at this too and see. So we can start see it now. All the properties that we're talking about: HTTP version, HTTP version major, HTTP version minor, socket the headers, the raw headers, some important information that we might not necessarily need. The method, the URL, the status code, status message, all different things. So now we've created the server, we've passed our request handler to it, and we've now told the server listen for connections on this port that we specify. If there's any error when you're attempting to listen for it, log the errors to the console. Otherwise, tell us that our server is listening for connections. Yes, so I is asking a question. So yes, it's a TypeScript definition file, but I don't want to start confusing other people that don't know about TypeScript. I don't want to go into details, but yes, it's a TypeScript definition file. So far, is everybody following? Is there anything that we didn't understand? The next thing I want to go over is the request handler itself. So I've gone over how we created the server. So let's talk about, okay, there are any questions? There should be some questions. This is your first time building servers. So I'm expecting questions. So why is nobody asking me questions? Oh, don't worry about TypeScript. Eventually, we'll get to that. Oh, Ante, you don't have any question? Kingsley, no question. Temitayo, no questions. Okay, good question. Where is the middleware in all this code? The middleware is our request handler. I'm going to explain the middleware for us here. Now, everything that's happening, I'll go through everything line by line. So yeah, we have another question. Is this how all servers are built? Yes, for the most part.
Um, for the good evening.
Yeah, hi. Sorry.
Yeah. For the content type, application
Yeah,
slashdation is
yeah.
how many content type do we have? Because based on content type is
So
how we handle information. So
yeah,
how many content
exactly.
types do we have?
So that's why servers, that's why people don't always write servers from scratch. They always build their servers on top of what other people have written. So uh, you have different data types you have to do. There's JSON, there's XML. It's possible that the request might be coming in form of HTML. You might have application URL encoded. Somebody might be trying to send a file to you. The files to also have different types. You might be sending a PDF file, you might be sending a text file, you might be sending an MP3 file, an MP4 file. The server needs to be able to handle all these different data types differently. That's why we have middleware. So the middleware looks at you can have a middleware that all it does is just looking at the data type. For example, now somebody already mentioned a common middleware that is used in Node.js development, server development, which is the body parser. The body parser, all it's doing is just trying to figure out what is in the body of the request and handle it appropriately so you can process that information. So there are a ton of content types. There are even custom ones. You can even define your own custom one that your client and your server, only your client and your server know about. I know, yeah, Awante already mentioned that she doesn't know where to start from. So I deliberately kept pausing throughout this whole session because this is very new. This is they are still writing JavaScript, but this is not like writing JavaScript on the front end where you're manipulating a UI. It's completely different. You're not dealing with a whole new world. So I can understand if this is a little bit confusing to some of us. And like I said, I'll provide as much support as I can to you guys so you can understand this. Okay, the next question we have is from Temitope, and he's asking that the core module is it when you import the HTTP and Temitope, can you voice out your question? I'm not sure I understand the way you have arranged it in the chat. Could you unmute your mic and just so we can all hear you again from it? Okay, so I'm just going to try and infer what the question that Temitope is asking. So if we go back to our index file where we define our server, we get access to the HTTP module from Node when we require it here. Essentially, when we say require, you're essentially telling Node that in order for this program to run, I require that I have access to the HTTP module. So what's happening here is that I'm requiring this. So this is going to give me access to the HTTP module, and I'm creating a reference to that module in this variable. The same thing is happening here. I'm requiring my local module, the handler here, and I am saving a reference to it within this variable so I can access it. Same thing with the port here. I'm defining that the value of this variable should be 3310. That is clear enough. So I'm going to just go back to the handler and talk about it. So the handler format. So mind you, yes, this session is being recorded. Exactly. There's really no difference between require and include in Node and PHP. In PHP has require. It has require once, and include. All those simple, all those similar things by making sure the dependency your program needs to run is available. So yes, somebody has asked a very, very important question. How do we link this simple server to our front end? So so in your front end now, I believe that you're currently building out your front end using tools like React. And React also has libraries that will allow you make HTTP to simplify the process of making HTTP requests. But at the same time, your browser has inbuilt code that allows you to make HTTP requests to servers. So your server will be defined. You deploy your server to Heroku where it will be running. Then your front-end client app will be making requests using maybe a third-party HTTP client or an inbuilt one, or using native JavaScript code in your browser to make that request. Toby, I hope that clears that up for you. Cool. Okay, so I'll go over this again. So our request handler is simply following the format for a request that the create server method requires. It requires a request listener, and if you look at the definition here, a request listener is simply a function that takes a request and a response, and it doesn't expect. It says void here because it doesn't expect a particular return type. So going back to it, so now we have designed a function that takes two parameters, a request and a response. So here, what we've just done is, I'm not sure you guys have seen this before. You might have seen it since you've been working with ES6 while working with React. This is called destructuring. So we are essentially to destructure this, we are pulling out these properties of this object, this request object, by destructuring it. So we have destructured the object and we now have access to these properties of that object as variables. That's why we're not able to log them individually here. Otherwise, would have been doing this instead. All right. So moving on now, unlike our initial version of our server where I just had this, and immediately a response came in, we just do response.end. I modified this and added some additional logic that does some checks. So the first check that we are doing now is that we are checking if this request comes in and the method is a post and the request has a header and that header has a content type that is of application JSON. This is how we are going to process it. So this conditional now defines how we are going to process this. So something to note is that the data type. So remember, when I taught you guys initial versions of when we were learning JavaScript, I taught you guys that variables all have types. Our request object here, which is a variable for this function, is of a type called incoming message. And an incoming message within Node is a stream, is a data stream, which means there are chunks of data within the stream. Like I remember I was trying to illustrate a stream to you using a stream a river stream in the village. So water is just flowing. That's how the data is coming to the server. So you make a request and the data is flowing from your client to your server. using the HTTP protocol as the pipe. So you can essentially put valves inside and control the flow. In our case here, this is our valve where we are collecting small chunks of the data that's getting sent on the stream. So like I said earlier, the request is of a type incoming message. So if we go back to this definition, we can see it here, incoming message. Let's say we look at the definition of it. So we can see it immediately here that the incoming message extends stream.readable. So essentially we can see that it is a stream, it's a data stream. So that means we can treat it like a stream and access it like a stream. That's why here we've created a simple placeholder here to hold the part of the stream. You know what? Let's actually do something to illustrate this. I'm going to log the chunks of data that are coming in. I'm going to make a request now. And I'm going to hide all of this for now. You open that by doing a command click. Somewhere, in order to open it, you hover on the thing that you want to see the definition of, then you hold your control and you click it. I'm using a Mac, so I'm doing command click. Okay, so to illustrate what the chunk looks like, I'm going to do that now. I've restarted the server and I'm going to send a response. So you can see this is the chunk. Let me hide this as well. So we are only seeing the chunk itself. So, like I said, it's a stream. That stream of data comes in form of buffers. So so I sent this string here, this JSON string. This is what I sent to the server as my data, as our application / our data type of JSON. But this is what the server received. This is by communicating over the HTTP protocol. You are not sending the raw data. You are sending it as a buffer of data. So it's parts and parts of it. So if this was a big file, you'll be seeing multiple lines. Let's actually try and send a big data file. We have a file called names. Let's add some more names and try that, and let's see what the difference. Oh, it's not going to work because our handler is set to JSON. So let's just use our JSON example for now. I also don't want us to complicate things too much. So this is the buffer. This is the representation of the data that we sent to the server. So let me try and expand these data sets. And see what's the difference. Add another field, call it occupation. Say software engineer. And we send this request. Can we see the difference now? The data size we sent is bigger, so the buffer is larger. You can see it's saying 30 more bytes. So because it's a buffer is another object, is another JavaScript object within the node context. It's also available on your browser as well. There's a buffer object on your browser. So a buffer is a collection of bytes of data. So we can now convert that to a string. Let's do something interesting now. Let's just say we didn't have this. Let's play here. Let's convert this to let me confirm how to do this thing again. We can change this to the binary representation so we can see what the computer is actually expecting. No, a buffer is not encryption. It's just a temporary store of data. So I'm going to convert this to binary now. So remember, I told you yesterday that computers deal in machine in binaries, ones and zeros. So this is what this data I'm sending. This object is JSON object. You see what it looks like to the computer. Uh, okay, that's strange. It's complaining. Hold on. I'm not quite sure we can do this. That we can convert a buffer into a binary. I'll need to confirm. But this fact that it is showing this type of errors. Um, Anyhow, let's move that. Mine might be a little too complicated. Or let me try something else. Usually, if I need to convert something to base 2, I just to binary, I just use base 2. So let's try this. That's strange. Why is it still? You know what? Let's just leave that for now. I'll figure it out later. Yeah, you can actually use to string to get a binary representation. I'll show you, let me show you an example outside this server example context. Let's say we have another file. Let's create another file called binary. Just create a string value. I call it 1 there. And just simply log string value to you cannot do. Oh, wait, that's wrong. Hold on. Oh, okay. Yeah. The problem is that we're trying to convert a string to a binary, but that actually is not going to work. See, we did 10,500. If we did this, it's going to work now. Yeah, my bad. That was a mix up. We can actually convert strings to binary directly. There's a long uh, there's a long process of converting it to a byte. It's out of the scope of our class. But anyhow, I think we get the point. Yeah. So back to our server. So essentially, what we are doing here now is uh, what we are doing now is since we know that our request is a stream, we can now we can essentially use stream events. So this on now is simply an event listener. So it says when data is received, take the data chunk, convert it to a string, and add it to the body. So this part now we have another event listener that says end. This simply means that when we stop receiving data, so that's when data has been fully transmitted. At this point, we cannot believe that we have gotten the entire data set and we have saved it inside this variable. We are now converting this variable into a JavaScript object. Otherwise, it will just be a string. There we can just we are just simply logging that body, and we are not telling the request to end by giving it a response. That's, that's why here in our clients, when we make the request, we are getting a response back that please add 5 minutes. I think somebody's mic is on. Can we check that our mics are muted? Hello? Can we check that our mics are muted? Hello, somebody's mic is unmuted. Hello, Maiwa, can you mute the person that is okay? It's gone now. All right. Did we understand what's happening so far? Yeah. Before we forget, we added another logic check to make sure that if a request method is a get method, we're not doing any additional processing. We are just ending the request. Yes, the ends method ends the response, ends the request response lifecycle. So we can even take this. Let's take this a step further, and let's add some new things. Let's make this a little bit more interesting. Okay, so at this point now, we're not saying um, let's expand this. Let's get rid of this. So when we receive a post request, let's do this. And when we receive a get request, let's do something else. So I want to comment all of this. And I'm going to create a file. Let's see. Okay, no, let's not create a file instead. Let's just define it here. We'll just create an array called employees and add people to it. And just add 2 people for the sake of time. First name, last name. Okay, so I'm going to say when we have a get request, and let's make this a little bit more complicated. So we're saying if let's have another condition here and say and request.url is equal to /. And then we add another condition that says /employees. So we assume that the first condition here, this is when we want to add a new employee. And the second one is when we want to fetch a list of employees. I'm going to use the get method for that. I'm going to explain to you what this is. So this is actually a paradigm. The way we have just written this code is a paradigm for API development. Okay. So we're going to do this now. So when we receive the requests, everything has been processed. We're now going to set a response now. We're now going to say, okay, we've gotten your request now. We are fine with it. So we're going to set the status code to 200. Now we have received the request. We are now going to add a header and to tell the server the client what to expect from us, that the response we're sending back is also JSON. Then, you know what, you can actually make this, you can simplify this a bit. But for the sake of learning, let's leave it as it is. Then let's create a body for our response. Let's call it a response body. And we're going to take the headers. Let's create a response body. And we're going to take the headers that we already have taken from the request and send it back in our response body. So we're going to take headers. So this is another powerful ES6 feature. It's called property inference. So if we just pass a variable called headers to this object, it's going to create a property called headers and assign the value of headers to that property. So it's a shortcut to writing this. So I'm just going to say headers method URL body. Let me put this here. That's the only thing we didn't have there before. Then I'm going to write a response now. So I'm going to say response.write. And I'm going to turn this response to a JSON response, what the client would be expecting. JSON stringify our response body. Then we can end the request. Then, when we receive a request that is a GET request, we can return a list of our employees at the top here. So we can do the same thing we did here. Take this. And we can say can simply say just do a shortcut and do this and write a response and say JSON.stringify our objects here, our array, and we do response.end, and we have now added some more complexity to the server that we have written. So we're going to demo this now. So we're going to run the server again with these new modifications. Then we're going to try I'm going to make a post request first. Let me clear this. Can we see the response we got back here now? This is our response. Let's remove this log statement here. Let's start this again. Sorry, I tried to start the server that was already running. So we've just made a post request now, and just like we expected, it's giving us the headers, the method, the URL, and the body as a JSON response because we stringified the response. We converted this object to a JSON response. So now let's test out the GET request. So we're now going to do that. So we're going to call http localhost 3310 / employees as we have defined. So let's actually do a test. Let's try and make a request without specifying the parts. Our request, are you seeing what is happening now? Our request never ended. It's just ongoing because we don't have any handler. We don't have any handler that is going to handle this type of request that is coming to the server without specifying any parts. Using the base part rather. So if we convert, if we change this, say, so if we change this and say, if we convert this to an else if rather, else if, then we add a catch all here and say else if after everything, if none of them match our rules, we just do a response end, and we send that same request. Our request will just end. Whereas if we send that same request, let's test out our employees request. I know I've just said a lot, so let's take a pause. So far, are we understanding or not? Is there something we're not understanding? For those that don't understand, this is going to be a recorded session, so you can always, it will be played back for you to like go over it. Hello, Kunle, do you have a question? All right, so I'm going to, since there are no questions here, I'm going to assume that we've kind of gotten up to speed with this. So essentially, 30 or so minutes is learn how to build the server. We've seen a middleware in action. I was thinking of doing a more complex example that showcased multiple middlewares, but that might take us outside the bounds of our class. I'll probably show us that on Thursday because I have another call coming up in the next 5 minutes. But I hope so far I've been able to impact some knowledge about the HTTP protocol and in Node.js to everybody. So I want us to
yes,
also to
I have a question. Like
carry on.
for the content type,
Yeah.
if it's a different content type, can we have a bunch of else if to handle the different content type?
Yes, but ideally that is not the way to do it. So I mean, in the next class, I'm going to introduce us to using a third-party module to make some of all this work easier for us. But because we are all learning how to create servers for the first time, we are writing it by hand. But that's like you said, we have to write multiple conditionals to handle multiple content types that our server might get. But in most situations where when you're writing servers, there's always a predefined set of, or there's a standard content type for transfer of that the data being transferred is going to conform to. Typically, is always the application JSON type. That's the most common one. It's basically the de facto uh, data format for HTTP requests on the web right now. You understand that? Yeah. So another thing I wanted to just point out before we end the class is that inadvertently we have just built an API without even knowing it. And I'd like for somebody to point out where where in this code where did we define the API? Can somebody just point it out to me? We just built an API on top of HTTP, the HTTP protocol. Anybody? Somebody? And I'm gonna take a shot at this. Somebody? Who else? Ayo. Israel? No, not the request handler. Any other person? Anybody want to try?
The path,
Exactly.
the path, because it's linking
Yeah.
with an interface.
Yes.
All right.
So that's exactly. So we use the part parameter in the HTTP request to define an API. So like I said before, an API is just an interface that just defines how you retrieve data or how you send data to a server. In our case here, we created an employee API that exposes a single part, but those parts react to different HTTP methods. So when we make a request to the slash employees part using the slash employees part, like we can see here, and the method is posts, we handle it in a different way. So essentially, we have not created a protocol. So if you send me a HTTP request using the post method and you specify the path to be slash employees, I'm going to respond by giving you data. Same way, if you make a get request and the path is slash employees, I'm going to give you a list of employees. But if you don't give me anything if you send a request that does not conform to the interface, so an interface is just like a contract. Like you're telling me, once you sign this contract, this is how you're going to communicate with me. So our last else statement is just basically says, so if any of the requests that come doesn't conform to our initially set out contract, I'm just going to end the request. So this pattern is called in API development, they call it the REST API development pattern, REST. There are other application API development paradigms or patterns, as it were. Let me quickly get to speak about REST here. So REST just represents representational. Oh Lord Jesus, these acronyms can be difficult to remember. It just represents. It means representational state transfer. And if you look at it on Wikipedia, Wikipedia calls it a software architectural styles. So it aims to create a specification that uses the HTTP methods as a way, HTTP methods and the paths as a way of defining an API for clients to communicate with servers and get information. Yeah, so today we've learned a lot. We've done a deep dive. We've seen how these servers that we use in our day-to-day lives can be built. And next week we'll be reviewing the assignments that you're going to get. Trust me, your assignments are going to be a little bit more tricky than what you've been getting, and they're also going to eventually lead up to being applied in your subsequent within your project. So after this class, by next week you're going to have another class about databases. Then I'll be back again and we'll still talk more about NodeJS. At that point, the assignments you get will now start contributing towards your project. But I hope everybody has had a good class today. As usual, I'll provide my email in the chat, and I'll also upload this code to GitHub and make the repo available to everybody via Slack. I'll share this with Maiwa. Maiwa will share it on Slack, and I'll also provide other reading materials to help. So if you have any questions, send me an email. I may not respond immediately, but I will respond. All right. A great class today. Thank you all for having me. Okay, Maiwa, do you have anything to say to the class before we all head out?
Hi. I don't have anything to say. I think it was okay. The only thing left for me to do is just to upload their videos for them. That's about all.
Okay.
Yeah.
Okay, so I'll put this code on GitHub and share with you, so you can share with them as well. Then some additional reading materials. So because this class, this is like an in-depth, more or less, Node.js is you have to do it hands-on. So this it will spill over to our class on Thursday. I'll connect with you and confirm timing for Thursday's
All right.
class as well within the week. All right. Goodbye, everybody.
Have a good night, everybody.
Yeah.